students, welcome back to my math class. Hopefully you all are fine and healthy at home. Today's session is for class 9, the chapter triangles. Already I have done one exercise 7.1. So today I'll do few theorems and a few sums of the exercise. So let's start the chapter triangles. Theorem 7.2. What is to be proved? Angles opposite to the equal sides of an isosceles triangle are equal. That means you have to prove the angles equal, and given that the triangle is an isosceles and the sides are already equal. So what is to be done? You have to mention first, as we generally write given part, here this angles of a triangle are to be mentioned. Let A, B, C be an isosceles triangle. Angle where the sides AB is equal to BC. Isosceles triangle ABC where AB equals to AC. You have to prove angle B is equal to angle C. To prove angle B equals to angle C, these angles are opposite to the sides. AB's opposite angle is C, AC's opposite angle is B. Therefore, to be proved that B is equal to C. So, if you keep it as it is, we can't prove. We need one line to be drawn over here, and how is to be drawn? So it will come in construction part. We will make a line which is a bisector of the angle. This angle will bisect. It's not perpendicular. Simply a bisector is taken. A, D, construction. The bisector, a bisector AD of angle A is drawn. Proof part. Now it's clear. Two sides are already given equal. As AD is a bisector, therefore this angle will be equal to this angle. So we have got, and this is a common side. So by SAS, both the triangles are congruent. If both triangles are congruent, then angle B is equal to angle C by CPCT. In triangle ABD and triangle ACD, what we get? AB is equal to AC, it is already given. BAD is equal to CAD, it is by construction, and AD equals to AD, it's a common side, it is given. Everything have to be mentioned. Common side. Therefore, triangle ABD is congruent to triangle ACD by two sides and the middle angle. Proved. Then the next theorem is as it is. Here it is 7.2, that one is 7.3 number theorem. What is it? Just a converse of this theorem. Here it said to be proved the angle equal, the sides are given. In that theorem, angles are given equal, sides have to be proved equal. And instead of this SAS, you will get ASA by the construction. Here the construction is a bisector AD of angle A is drawn. Already I mentioned that this angle, this bisector was not perpendicular, but in another one, what is to be drawn? It's a bisector, and moreover, it's a perpendicular also. It's a perpendicular bisector of the side. Clear? Now it's theorem 7.3. Just converse of that theorem, previous theorem. The sides opposite to equal angles of a triangle are equal. Sides are equal to be proved. It's given that angles are equal. So angles we have made equal. This time we will make the perpendicular bisector of the side. In the previous one we made the bisector of angle A. This time we will make the perpendicular bisector. Two words I'll show you. So let's write it first. Let ABC be the triangle where angles are equal. Angle B is equal to angle C. To prove AB equals to AC. Construction. AD is the perpendicular. AD is drawn as a perpendicular bisector of BC. AD is a perpendicular bisector of BC. This is a short form of perpendicular, and this is a bisector of BC. Earlier it was not of the side, it was the angle bisector, this time the side bisector. So from these two words we have got 2 points. One is this angle equal, these two angles are equal, and secondly bisector of the side. So BD equals to DC, therefore these two sides are equal. And earlier B was equal to C. That means what? I have marked differently so that you can identify easily. So by angle, side, angle, both the triangles are congruent. Proof: in triangle ABD and ACD we have what we have. The previous point you write B is equal to C. Here you write given this angle equals to this angle. Angle ADB is equal to angle ADC. Both equals to 90 degree by construction. And BD equals to CD. This is also by construction. Therefore, triangle ABD is congruent to triangle ACD, but this time it would be SAS. Therefore, BD is equal to CD. Here by CPCT in the earlier one also to be written. In the previous theorem it was forgot to write CPCT, that has to be mentioned, that because it is after being congruent both the triangles we have got BD equal to CD, so it is CPCT. Okay, now it's question number 1, exercise 7.2. Here it is said In an isosceles triangle ABC, ABC is an isosceles triangle. AB is equal to AC. The bisector of B and C intersect each other at O. So while drawing the bisector of B and C, very careful, just to the middle you have to draw, and it meet at a point O. Then OA has to be joined. Thus there form 3 triangles. You are to prove that OB equals to OC and AO is a AO bisect A, means these 2 angles are equal to each other. So given part you write, given in isosceles triangle ABC, AB is equal to AC. To prove number 1, BO equals to CO or OB is equal to OC. Number 2, AO bisects angle A. This is B. Proof. It's a proof part. This you mention first. OA is joined. Earlier we have, since AB equals to AC, since AB is equal to AC, therefore by the proof the angles opposite to those sides are also equal. AB's opposite angle is C and AC's opposite angle is B. C is equal to angle B, or we can say angle B is equal to angle C. Angles opposite to the equal sides are equal. Now for proving a BO equals to CO, that means if you can prove this angle is equal to that angle, means OBC is equal to OCB, then both the sides will be equal by the same proof again. Theorem. Make it half. Angle B is equal to half of angle C. This time half of B we can take this angle OBC, and half of C we can take OCB. Here you write, since OB and OC are bisectors of angle B and angle C. So if this happens, opposite to those angles, the sides are also equal. Here we have used theorem 7.2, 7.3 theorem, and here we are using 7.2 theorem. So opposite to this angle is OC. It's very easy to find the opposite side. Just you omit this middle letter of the angle and then OC, and here if you omit this middle letter, then OB. It is a technique of finding the opposite sides and opposite angles. So here you have to write sides opposite to equal angles are equal. It is number 1 proof. Now it's the second part. It's the second part. Proof number 2. To be proved, OA bisect angle A. OA bisect angle A. That means this time we have to take these two triangles. Now try to make both the triangles congruent. Earlier we have OB to OC. In the given part we had AB is equal to AC and OA is a common side. So 3 sides we have got. By SSS both the triangles are congruent. Therefore, these two angles are equal to each other by CPCT. In triangle AOB and triangle AOC, what we have? AB equals to AC, OB equals to OC. It is given part, it is from above. Above means from the above proof, and OA is equal to OA. It's a common side. Common side. Therefore, triangle AOB congruent to triangle AOC. This time it would be SSS. After making the triangles congruent, any parts, whatever you like, whatever you need, is to be make equal. This angle is to be made equal to that. BAO, or you can say OAB is equal to OAC by CPCT. If the angles are equal, that means what? OA must bisect the angle A, that is AO or OA, same. AO bisects angle A. Proved. So 2 parts we have proved. Now it's question number 2. In triangle ABC, AD is perpendicular bisector of BC. So let's make the triangle ABC. AD is a perpendicular bisector of BC. Then show that ABC is an isosceles triangle. Now for proving it is an isosceles triangle, isosceles means 2 sides you have to make equal, and it is mentioned also that with the sides AB equals to AC. Now from the given part it is clear that AD is perpendicular bisector of BC. So 2 words perpendicular, from the word perpendicular we have got this angle is equal to this angle, and bisector of BC means BD is equal to CD. So here are the 2 sides. The third side is common. Again this is a common side. Thus we have got by side, angle, side, both the triangles are congruent. When both the triangles congruent, AB equals to AC by CPCT, that means 2 sides equal, so it is an isosceles triangle. To be written the given part, it is very simple. You can follow the question only. The same thing have to be mentioned. In triangle ABC, AD is the perpendicular bisector of the side BC. To prove ABC is an isosceles triangle with AB equals to AC. Construction, no need of writing construction. Proof part, mention the triangle in triangle ABD and triangle ACD, we have what we have, that angle ADB is equal to ADC, which is equal to 90 degree by construction, by given part, by given. Simply you write given. And BD is equal to CD, this is also given, and the last point AD is equal to AD, that is a common side, common sides. Therefore, triangle ABD, the same triangles congruent to triangle ACD by SAS. Therefore, AB is equal to AC by CPCT. That is, ABC is an isosceles triangle with AB equals to AC. Proved. So with this, I'll wind up my today's session. I'll be back again with some of the more questions of the same exercise. Till then, bye bye.